Good morning, students. Students, this lesson is of class 10th for the subject of physics, and we will be doing uniform circular motion in this chapter, that is the third exercise of chapter 1. So you all are requested to open page number 15. Children, you must be knowing that Earth revolves around Sun in a circular orbit. Similarly, electrons revolve around nucleus in a circular orbit. So children, as we have discussed in class 8th also, that in uniform circular motion, what are we having? The particle is revolving in a circular path, and the velocity will be always acting tangentially outward. Even if the magnitude of speed is constant, still the direction of velocity is different. So even when you are having uniform speed, the direction of motion, children, by direction of motion, I mean velocity. So the direction of motion of the particle changes at each point of circular path. Now you are requested to see figure number 1 and write the answers of the question which I am just going to ask you. So first thing is velocity constant in a circular motion? Tell me, students, is the velocity constant? If you see figure 1, can you say in figure 1 that velocity is constant? Give the reason also for your answer. Moreover, also tell that is it correct to refer uniform circular motion as accelerated motion? So children, after writing the answer, you may resume the further lecture to check your answer also. So the velocity in case of uniform motion is acting tangentially outward. See figure 1. The velocity is acting tangentially outward. Thus, velocity in this case is non-uniform because the direction of velocity is continuously changing. Since the velocity is always acting tangentially in an outward direction, the direction of velocity or direction of motion is continuously changing, due to which the velocity is variable in figure 1. And if it is variable, that means acceleration will not be zero, and hence it is also known as accelerated motion. But children, in case of uniform linear motion, speed is uniform and object is moving in a straight path. So what I am going to say here, that in uniform linear motion, the object is covering equal distance, same distance in equal intervals of time. So the object is covering same distance in same time and in same path. Thus, here speed is also uniform and velocity is also uniform. So since the velocity is uniform in uniform linear motion, then we can say that acceleration is 0 meters per second square. Thus, uniform linear motion is an example of unaccelerated motion. Children, uniform circular motion is accelerated motion, and uniform linear motion, linear means straight line motion. The uniform linear motion is unaccelerated motion. Children, today we will learn a new kind of force. It is known as centripetal force. So whenever a particle is moving in a circular path, a particle is moving in a circular path. This word has to be written. It is very important. Whenever the particle is moving in a circular path, continuously changes its direction of motion at each point of its path, which is possible only under the influence of a force which is termed as centripetal force. So children, that means there is a force which is always acting inward when a particle is moving in a circular path. So the definition of centripetal force is given on page number 2 of the PDF. So children, what is this? Let us see the definition. So centripetal force is the force acting on a body in a circular path. So centripetal force will be always acting if the body is moving in a circular path, and this force is, what is the direction of the force? Direction towards the center of the circular path. Children, as we know that force is a vector quantity. What is force? Force is a vector quantity. That means it has magnitude as well as direction. So children, centripetal force is the force acting on a body moving in a circular path in a direction. Now let us write the direction. In a direction towards the center of the circular path. I hope this is clear to all. So students, whenever a body is moving in a circular path, velocity is taking the body outward. Velocity is acting tangentially outward. So if an object has to go from point A to B, then there must be certain force which brings the particle inwards. That force is known as centripetal force. So children, let us see certain examples of centripetal force. It is a must force for a body moving in a circular path. Yes, students. Now see, this is moon revolving around Earth. Velocity is acting outward tangentially, which I have shown with a red arrow, and a green colored arrow is representing centripetal force, which is acting along the radius towards the center of the orbit. So see students, whenever the object is moving on a horizontal surface in a linear motion, the direction of force and the direction of velocity. Direction of velocity means direction of motion. They are along same direction. Force and velocity are acting along same direction. This is a linear direction, uniform linear motion. But what happens when a body is moving in a circular motion? See, there are some examples which you can see right now. When you are revolving the ball, you are rotating an molten iron cast and spinning off a ball. Now children, let us see what happens when a ball spins. If you throw a ball, generally it moves along the same direction. That means the direction, suppose the ball is moving in a straight direction. Now children, if I apply a force perpendicular to the direction of motion, this blue line is the direction of motion, which you can say direction of velocity. red colored line, I am showing you the direction of force applied. So if I apply the force perpendicular to the direction of motion, what will happen? The path of the ball will change in this direction. See? Again, just have a look, children. What will happen? What I am saying that if you apply a force downward, the direction of motion changes. Now similarly, let us apply a perpendicular force at this point. Again, the ball will change its direction of motion. Now again, apply the force perpendicularly in an inward direction. Just see what is happening. The direction of motion of the ball has changed. What kind of figure you can see? It is kind of circle only, very close to circle. So I have applied forces at a very larger distance. If I apply force at a smaller distances, if I am applying the forces quite regularly, see at the smaller distances, now you can see a perfect circle coming across. So this is the red arrows is showing you the centripetal force which you are applying inward such that the body can complete a circular path, while the velocity direction of motion is always perpendicular to the applied direction of force. So I hope the concept of centripetal force is clear. Now you can see Earth rotating, moon revolving around Earth, and there is a table, rotating table on which you have placed a box. It is the same kind of rotation that is acting centripetally inward. So students, the example of centripetal force, moon revolving around earth or earth revolving around sun, that is also the same thing. Then again there is one more application of centripetal force. When you whirl around a ball with a string, that is also an example of centripetal force. A rotating table having a box on it. So all these three are example of centripetal force. Children, there is one more kind of force which we will be studying, that is centrifugal forces. In physics, though, we are not talking about centrifugal forces because they are fictitious force or virtual force and they are not actually present. Instead of centrifugal force, we are having pseudo forces. But that pseudo forces are not in syllabus. Thus, let us see what is centrifugal force. In centripetal force, there was some force which was acting inward when a body was moving in a circular motion. But in centrifugal force, there is a force which is acting outward. It is acting outward. Now this is a beaker. It is put it in a rotating can. You can have you can think about your mixie grinder in which you want to make milkshake. So when you put a milk inside it and you put that mango shake, so what will happen when you switch on the mixer? If you see, this revolving around the axis will allow the fluid to move away from the center. When this mixer spins on its own axis, what happens? It allows this thing happens. This might you have experienced. Yes, so there is a force which is acting in an outward direction, which is taking this fluid in an outward direction. That force is known as centrifugal forces. Which forces? Centrifugal, F-U-G-A-L, centrifugal forces. So students, in the example of centripetal force, you can have in an atom, an electron is also moving around a nucleus in a circular path for which the required centripetal force. Now, listen, if you are having a nucleus, you know that nucleus is positively charged. What is the charge on a nucleus? Nucleus is positively charged. Okay, but the electron, that electron is negatively charged particle. This is negatively charged. Whenever this electron is near to the nucleus is pulling this electron towards itself because of electrostatic attraction. Opposite charges attract each other, students. Positive charge of nucleus will attract negative electron. So what will happen? Yes, this attraction, this electrostatic attraction is providing the necessary centripetal force. So centripetal force is actually obtained from the electrostatic force of attraction of the negatively charged electron with the positively charged nucleus. Similarly, when Earth moves around the Sun in an elliptical path, then the gravitation force of attraction between the Sun and the Earth provides the necessary centripetal force. So children, now you can take a break and read the further examples given on page number 16 of your physics textbook. There are some few examples written under the heading of centripetal force. Kindly pause this session and go through those examples. So I hope you must have gone through the examples and understood that examples. Now coming to the next part, that is centrifugal forces. Children, as I have shown you right now only, what are these forces? Centrifugal force is in a direction opposite to the centripetal force, but it is same in magnitude. So children, a force is assumed. Why assumed? Because it is not actually present. So force assumed to be acting on the body in a direction, see, in a direction away from the center of circular path. It is acting away, not near, it is going away from the circular path. So centrifugal force is not the actual force. It is just a reaction to centripetal force. Thus, children, centrifugal force is usually known as fictitious force or non-real force or a virtual force, which is observed by an observer moving in a circular path along with the body. Actually, instead of centrifugal force, we are having pseudo forces. There are some forces which is acting outward, but yes, those forces are read in higher classes. So for this class, just understand the direction of centrifugal and centripetal forces. They are equal in magnitude because their value is same. If centripetal force is 10 Newton, then centrifugal force will also be 10 Newton. But the directions are opposite. Centripetal force was acting on the body and towards the center of the circular path, while centrifugal force will be acting on the body moving in a circular path but away from the center of the circular path in which the body is revolving. So I hope this is clear, children. You are required to do question number 5, 9 and 14 in your physics notebook. And with this, I am ending this interactive session. Thank you, students, and have a nice day.